Hello, everyone. Greetings. Um, Glad to have you, Engineer Tolulope, today for joining us, and thanks for all the audience who's joining us today. Um, Let me first introduce our speaker today for this topic, who's Tolulope. Uh, Today we will have the use of the artificial intelligence in the power transmission and Um, let's have a brief bio about our speaker. Tolulope is a graduate engineer at ESP in Ireland. Uh, he is engineer and he has obtained a master degree in mechanical engineering from the University of uh, Lamarck. Is that correct?
Yes,
Yeah,
yes.
yeah. He worked as an overhead lines design engineer at the ESP, and he's currently working as an engineer in the program management division at the same company, which is ESP Networks. Uh, glad glad to have you, Engineer Tololope, again, and you may begin.
Yeah, great. It's an honor to be here. So, good evening to everyone. Uh, so today I'll be talking about the use of artificial intelligence in power transmission. I've heard that this is quite an anticipated topic. So allow me to get started. Uh, as Ahmed said, my name is Tolulope Mayomi, and I'm a graduate engineer in ESB in Ireland. So, as you can see in the image in front of you, there's a lot of, I'd say, uncertainty with regards to what exactly is artificial intelligence. You get like different people saying different things. Like some people say, like AI robots are going to take over the world, and just different things are being said about it. And today, there's not really a standard definition of what constitutes an artificial intelligence system. Uh, However, if we go to who is Alan Turing, who is widely credited as being the father of artificial intelligence, he speculated about thinking machines that could reason at the level of a human being. So he basically defined artificial intelligence, if I could summarize it, as just trying to um, as training computers to display human behaviors. So things like human beings learn, and trying to see if you could make computers learn. I'm not, although I'll be talking about artificial intelligence today. I'm not an expert in AI. Neither am I an expert in data analytics. My background is in mechanical engineering, so I thought it would be better if I um, introduce the video, and maybe the video would come from someone who's more of an expert in artificial intelligence. I'll be talking about the applications of AI in power transmission, which I have some experience with, but just to give you a more theoretical background into the topic, I would be I will just share the video with you right now. So yeah.
Engineer,
Yes,
is the video is playing?
yes. Can you see it, the video?
No, not
Oh,
yet.
okay. Sorry. I'm sorry. I'm just going to try to. I'll stop sharing and I'll try to
Share the
share
video.
again. Yeah,
Yes,
just hold on.
thank you.
Uh, uh, Let me see. Share screen. Uh, can you see now? Can you see the video?
Yes, it's now clear.
You can see it now.
Yes.
Okay, great, great. All right. So sorry about that.
Engineer Tolo, sorry. Just open the audience because we cannot hear anything. Share it with the audio, please.
Oh, okay. Uh, uh, let's see if I can. Uh, Sorry. Let me just quickly
Yeah,
try to. If
you
I can't
may
get this out, then I
yeah
will.
you may share the screen, all right, and then
Yeah,
there's an option there. It says yes.
yeah. Then I will try to share again. Okay.
Yeah, great.
Share screen. Then share audio. Okay. Great. Uh, yeah. Uh, okay. So you please tell me if you can hear.
I'll confirm. Yeah,
Can
I'll
you hear?
confirm.
Can you hear now?
No, there's no.
Uh,
Yeah, there's no voice
okay.
responding.
If you can't, never mind. That's fine. I will just. I will explain it myself. That's fine.
I think you may open it from the same screen, the
Um,
same YouTube channel.
yeah, I think that might be tough to do. Okay, let me just see if. Okay. Okay. Can you see it now? Sorry, it's an ad. Okay. Can you see it now?
Yeah, I can see, but there's no. Yeah, increase it. No, still,
Uh,
unfortunately.
can you hear now?
You may go on. There's no. Unfortunately, there's no sound.
Okay. That's fine. Sorry. Unfortunately, these things happen when
Is it
whenever.
important to hear the explanation, or the just we should understand from the drawing?
Yeah, I think it's an introduction, but I will try to give an explanation as best as I can. Uh,
Okay, all right, go
yeah.
ahead.
Okay. So sorry once again. These things happen. It is it's what happens nowadays with everything being virtual. But yeah, artificial intelligence basically is a field of computer science where you try to simulate human behavior in computers. And artificial intelligence has been in development for a long time now. But with the increase in the amount of data and also the increase in computational capacity, it has gained like a it's more important now, and the applications are more diverse now just because of those reasons. There are several fields of artificial intelligence, and three of them, as you can see, are in the um, image in front of you. There's soft computing, machine learning, and
Engineer
deep.
Tolulope,
Yes.
please share the presentation.
Sorry.
You're not sharing the presentation. You may
Oh.
please share it again.
Oh. uh, okay. I will screen. Okay. Can you see the screen now?
Yeah, all good.
Okay.
All
Great.
good.
Uh, okay. Yeah. I'm just going to start again. Sorry about that. So, artificial intelligence is a field of computer science which aims to simulate human behavior in computer systems. Um, Artificial intelligence has been in development for a while now. I can't see when exactly it started, but it's not as recent. I know it has been in the news just recently, but it's actually been in development for a while now. And there are several reasons why it has gained prominence recently. And some of these reasons are that there's much more data available than there was in the past. The algorithms are better, and finally, I'll say the increase in computational capacity has made those algorithms even much more effective at performing the task that they were designed to do. There are various aspects of artificial intelligence, and some of them are shown in the image in front of you. There's soft computing, there's machine learning, and there is deep learning. For the applications that we will be talking about today, I'm going to mostly focus on machine learning. And machine learning is a form of artificial intelligence where you use data to train a computer to make certain decisions. Now, there are three aspects of machine learning: there's supervised, unsupervised, and reinforcement learning. And the three different aspects of machine learning basically are categorized based on whether or not you um, provide the system with the answers to the while training the system to the solution you are looking for. So I'm going to be mostly looking at applications that involve supervised learning, but the applications to power transmission are not limited to just machine learning or supervised learning. So, for example, as you can see in the image of the cat and the dog, suppose we want to train a system to be able to label cats, so to be able to understand what a cat looks like or what a dog looks like. So let's say you create certain pictures. Now, depending on how accurate you want the system to be, that will determine how many pictures you're going to use to train your model. But you create several pictures of cats and dogs, and you label those pictures. And what you do is you give those pictures to what is known as a neural network. And a neural network basically consists of several layers. So as you can see in the image in front of you, there are four layers in this system. And basically, what happens is that for each layer in the system, the computer or the algorithm, it's creates a set of values. It creates a set of values which are known as weights and biases, and each value in that in that neural network is used to learn. The computer uses those values to learn what a cat looks like. So let's say if you train the computer with a series of images that look like cats, the computer will tune each value in each layer to a certain number, and it's kind of an optimization algorithm, and it uses that algorithm to figure out what a cat looks like. And you can also use it to train the algorithm on what a dog looks like. And in that case, it will use different values for each layer in the network. And when you want to get a useful result from the computer, you could give it, for example, a new image of a cat that you never trained it on. And the computer should be able to give you with probability, certain level of probability, what it thinks that image looks like. So in this example, for example, if you train the neural network on images of a cat, and then you give it a new image of a cat that you had never trained the system on, it should be able to say with some certain level of confidence whether it thinks it's an image of a cat or it thinks it's an image of a dog. So what is power transmission? I think most of you will be more familiar with the concept of power transmission. Power transmission just involves moving electricity from where it's produced to the final consumer. And there are usually a series of steps involved. Usually electricity is produced at a generating station, and the voltage is stepped up to a certain level of voltage so that it can be transferred over large distances, and w- from the from the overhead lines or the transmission lines, it's then sent to a substation where it is where the voltage is stepped down to another voltage for it to be passed across distribution lines, and from the distribution lines it's usually sent onto the final consumer. Now, there are different applications of there are different applications of artificial intelligence in transmission, and I just selected some of these applications, but the applications are not limited to these ones. There are even more applications, and so I might venture to say the sky is the limit with what you can do now with artificial intelligence systems. But some of them include asset management, anticipating and preventing power grid failures, detecting power grid faults, balancing the grid, differentiating power system disturbances from cyber attacks and energy theft. Now, for this topic today, I would mostly be talking on asset management and balancing the grid, but I just wanted to show some of these examples just to highlight the fact that the applications of AI in power transmission today are actually quite varied, and they're not limited to just these ones. So to start with, I'm going to talk about an application which is related to safety. So as you can see in the image in front of you, what you have there is a transmission line or an overhead line in close proximity to a dwelling, so a house in somewhere in Ireland. And in Europe, we have a code EN 50341, and it states that it states that lines such as this, where we have towers in close proximity to houses, parks, playgrounds, schools, places where there's the probability that individuals could come into contact with such towers, have to be assessed. And the reason is, in cases where there are earth faults in those towers, we should have conducted tower footing resistance measurements in the towers, in the areas around those towers, to ensure that there's no risk to the public, or the risk is minimized to the public from such earth faults. Now, in order to assess those towers, we created 3 levels of classification. So we tried to classify all the towers on our network into 3 levels. So level one level one towers that were classified as level one were referred to as often frequented towers. We had level 2 and level 3 towers, and we were mostly interested in figuring out how many level 1 towers were on our network. And as you can see, this is just like an image of the preliminary classification we conducted. Level 1 towers, as you see here, they are usually situated around buildings and around residential areas. Level 2 towers might have 1 or 2 buildings around, but they are not in such close proximity, or the risk of access for the public to the towers is not considered to be high. And then level 3 towers are just towers which are maybe in rural areas, there's no one around them, and if even in cases of earth faults, we estimate that there should be no risk to the public. So for a network, so in Ireland, we estimate that we have about 13,000 earth structures on our network. Hence, in order to carry out a manual classification, we would need a team of 2 individuals working for 2 years in an appropriate GIS environment to classify each tower under level 1, level 2, or level 3. However, we also discovered that machine learning offers the potential for rapid and accurate classification of towers at half the estimated duration and cost of a manual approach. So we estimated that we could classify all 13,000 towers in half the time and at half the cost of using a manual approach. So in order to carry out the classification, we decided to just conduct a proof of concept. So what we did was that we took images of the already classified towers that we conducted through a desktop assessment. And what we did is we trained a neural network, kind of like how the neural network in the previous slide was trained to recognize images of cats. So we trained it to recognize images of level 1, level 2, and level 3 towers. And then we gave it images that we hadn't trained it on initially. And we wanted to discover how accurate the neural network was at classifying the towers. So in determining the accuracy of image classification, which is a form of machine learning, three values are usually used. You have precision, you have recall, and then you have average precision. So in precision, it basically is, for example, if I use an example, if we test our neural network on 30 images of level 1, level 2, and level 3 towers, we want to determine how many of those towers does the system get right. So as you can see here, it was about 70% or 70% precise at predicting um, level 1, level 2, and level 3 towers. Then recall gives you an indication of how accurate it is within each level. So let's say, for example, um, if we divided our classification into three levels, level 1, level 2, level 3, how accurate is the neural network at predicting level 1 towers? How accurate is it at predicting level 2 towers? And how accurate is it at predicting level 3 towers? And as you can see, we have approximately like a 67% accuracy, and then average precision is just a combination of both precision and recall. And so initially we trained the system and we obtained our results, and I guess the accuracy wasn't as high as we were comfortable with. So what we decided to do was to train it on kind of went with like a black and white approach. So we just trained it strictly on level 1 and level 3 towers, so often frequented towers or not often frequented towers. And as you can see, the accuracy improved dramatically. You have here almost a 98% level of accuracy um, for predicting the towers. Then another application of artificial intelligence in power transmission is in vegetation management. Now, vegetation management is a big issue in managing any power transmission system. And the reason for this is that improper vegetation management can cause blackouts. It can increase the safety. It can increase the risk from overhead lines for damages to members of the public. And we also have a term in overhead lines known as sheltering. So when you have trees and other vegetation along the corridors of overhead lines, what they do is they reduce the wind cooling effects for the overhead lines, and this reduces the amount of current usually that you can pass through the line. And when that occurs, obviously that's a negative effect because you want to transmit as much power as you can while without violating your safety clearances, of course, through your lines. So how is vegetation managed in overhead lines? Well, today most most systems are managed through the use of lidars. So as you can see in the image in front of you, what happens is we send usually helicopters, drones, cars. We send this delivery systems with lidars, and what they do is they take data, data from along the length of the line, and we use this data that they obtain to create 3D models of our power lines, and we're able to use those models to tell which areas along the line are trees growing, or are the trees which are growing infringing on the, or let's say violating the safety clearances which we have determined. And when that happens, what we do is we usually send a team to go and cut the vegetation growing along that line. However, if you if you just imagine a system, in most systems, you have power lines which are thousands of kilometers long. And so the time it takes to send like a helicopter or a drone to capture your entire system and to collect that data, process it, and create 3D models, and then figure out where the trees are on your network, it takes a very long time. And so what happens is that there's a lag between when you send out, when you conduct your lidar surveys and when you are able to process that information, and that could be dangerous because during that lag period you could have trees which have grown beyond your the appropriate safety clearances that you have determined. Now, artificial intelligence offers a very interesting solution to this problem, and I'm just going to talk about two potential methods that are right now state of the art. So in one system, what you may do is you may collect this data from your lidar surveys, and what you do is through you combine that with an artificial intelligence system to to identify what specific tree species is growing in your area. So suppose we are able to tell what type of trees are growing around the lines, we might then, even if there is a lag between when we received the lidar data and when we conducted the model, if we have if we're able to accurately tell what trees are around the lines, and we're able to collect information on things like the precipitation around that area, we might be able to even estimate how much the tree will have grown between when we conducted the survey and when we did our models. So that will give us a more accurate representation of the actual picture of the line at that moment, and that's more accurate than what is being done traditionally. Another very interesting approach being taken today is through the use of satellite data. Now, if you imagine, you might estimate, you might figure out that satellites could collect data much more rapidly than through the use of drones or helicopters. So let's say, for example, by using satellite data, you might be able to collect data on your entire network every 15 minutes. And then if you pair that with an artificial intelligence system that is able to visually recognize, so an artificial intelligence system that is able to visually recognize power lines and vegetation across the lines, you might be able to, in every 15 minutes, get a picture of what trees are growing along your lines and where they are growing. And this could potentially revolutionize the way vegetation management is done in power transmission. The next application is the use of artificial intelligence in inspections of transmission lines. Now, I brought this. I included this slide here because I think if I created a survey before I give this presentation, and I asked people to maybe name one application that could come off the top of their head, I think most people would say, well, yes, maybe just sending a drone around the line and collecting images, and then using an AI to identify where faults exist. For example, as you can see in the image, might be the most obvious application of artificial intelligence in power transmission, and they would be right. However, I included this slide to just talk about some of a limitation in applying machine learning or artificial intelligence in power transmissions. And this is that the amount of data usually required for training a neural network, for example, the neural network you saw in one of the slides at the beginning that was used to identify cats and dogs. Now, suppose we want to be able to identify cats, or in this case, faults of insulators along the entire line. We can't train the neural network with just small amounts of data. We have to, in order to be able to accurately determine when faults exist, we have to be able to train that neural network with thousands of images, and those images have to be as diverse as possible, so covering almost every type of fault that we think is conceivable in order to be able to accurately use that model in inspections. However, it's not easy, or it's not, I think a better word might be, most utilities don't have access to that data. And it's usually easier to maybe send a human inspector to go along the length of the line and carry out inspections, rather than using a machine learning system or artificial intelligence system to do that. And this is one of the limitations right now with applying artificial intelligence in power and transmission. It's just, I would say, it's also one of the limitations of applying artificial intelligence in most applications, just the amount of data that's required. Now, there are potentially some ways around this. So today there is talk about the use of synthetic data sets, and synthetic data sets will just be, they're called fake data, but they're mostly like, they are simulations that are created. So you create a simulation of what a fault should look like. So let's say we don't have images of what a broken insulator should look like, maybe in our repository, in if we're a utility, for example. But what we could do is simulate what that could look like, and use that to train our machine learning model to identify what images of broken insulator sets should look like. And this is being applied today by some artificial intelligence providers that are used for um, inspections of overhead lines today. And the accuracy is improving every day, but it's still a limitation that it has to be overcome for more widespread applications of artificial intelligence in transmission systems. The final application of dynamic line of artificial intelligence in power transmission is in dynamic line rating. So this is just used in balancing the grid. As you can see, I think in the image in front of you, Ireland has a very high wind penetration in our energy mix. So in 2019, for example, approximately 32.5% of the electricity that was produced that year was from wind energy. However, due to several constraints on the grid, such as the amount of synchronous, asynchronous penetration allowed. So one of the limitations is that uh, there is a limit in Ireland, for example, for I think there's a limit for 65% of asynchronous generation sets that can be integrated into the network. There are also other limitations, such as balancing supply and demand, and also I think a big limitation is that the grid that was created in Ireland was not created with renewables in mind. And so what you have is, when we have a lot of renewables being produced, sometimes we have to we can't accept all that electricity onto the grid. And so a term which is known as dispatch down is some of that power is dispatched down, basically. And one of the methods of reducing this, and so one of the methods of increasing the amount of wind energy that is supplied to the grid in Ireland, is the use of dynamic line rating. So as I mentioned previously, one of the limitations in using wind energy is that the grid in Ireland was not designed with wind energy in mind. So there is a limit in the amount of electricity, usually in areas around wind farms, that can be passed along the power lines in those areas. And one of the reasons for this is because when we design power lines, we usually create have clearances. So we have ground clearance limitations in mind, just because we take the risk of the lines coming too close in contact with the general public if we pass so much current across the lines. And in order to estimate the amount of current that we can pass along a certain line, which is a term known as the ampacity of the line, we usually make several assumptions. One of the assumptions we make is that there is little to no there's very low wind passing along the line. And if we make these assumptions, then the wind cooling effects of the line may be assumed to be negligible. However, especially in areas where there are wind farms, we can assume that when there is a lot of wind and wind farms are producing electricity, there should also be a lot of wind available to cool the conductors. As you can see in the image in front of you, you have the so in this curve shows you the amount of current that's passed on the line at that moment. However, these two curves show you what could potentially be passed along the line without violating your safety clearances. Now, the reason why you have so much more capacity in your lines is because we're actually taking into account what the actual weather conditions along the line are. In this case, which would be done using dynamic line rating. Now just shows you this slide here just shows you the formula used to calculate the ampacity of line and used to calculate to calculate the amount of current that we can pass along a line. So how is artificial intelligence useful for dynamic line rating? Well, in order to integrate dynamic line rating into power transmission, grid providers have to not only tell what the weather conditions are along the length of the line today or at the present moment, because electricity is sold in days ahead market. So electricity is sold days ahead of time. Grid operators also have to be able to estimate what the weather conditions along the length of the line have to be. Now, weather forecasting is a very expensive application. So, um, artificial intelligence today has applications in weather forecasting as well, and can also be used in weather forecasting for lines for dynamic line rating. So, I'm just going to show you a video of a system that was created using off-the-shelf technology. Now, this system can give weather forecasts every 100 milliseconds, and it costs about 10,000 euros to produce. Now, a typical system which would give you the same forecast at that same level of accuracy would would take much longer to compute, and um, it would also cost a lot more. So you can imagine trying to integrate dynamic line rating into your system when you have to produce weather forecast, and it's really expensive to do so. That would limit the amount of integration of dynamic line rating that can be added to the grid. So if you just permit me, I'm just going to try to share this video. I hope it works, and showing you just like a system that was created for weather forecast. And you wouldn't need to watch and to you wouldn't need the use of audio for this. It's just a video that you can watch and see how the system works. So I'm just going to try to share again. Uh, So as you can see, this would be actually this would be the actual weather conditions in an area, and this would be the predicted weather conditions using the system. And as you can see, there's very close, its system is very accurate at predicting what the actual weather conditions is like. And so if you could just imagine um, um, dynamic line rating operators using this to predict what the weather is along the length of lines where they implement their systems, this could dramatically reduce the amount of money that's involved in applying dynamic line rating systems, and could also increase the amount of renewables that are added to the grid. Okay, so just to uh, going to try to share my slide again, sorry. Yeah, so to summarize, artificial intelligence is a useful tool currently used in various areas of the power transmission industry, such as asset management and system operation. And like I said earlier on, there are much more applications than this. This is just, let's say, an introduction to some of the applications uh, that involve the use of artificial intelligence. However, there are still challenges that remain, especially related to the amount of data required to train accurate models. Uh, you could imagine transmitting or moving power from one area to another. You have to be as safe as possible, and so the systems, if we integrate artificial intelligence into our systems, you have to be extremely accurate, just because safety is paramount, and system reliability is also paramount in power transmission. Thank you.
Thank you so much, Engineer Tolulope, for the amazing webinar. Uh, we will having couple of questions from the audience, uh, if you don't mind.
Yeah, no problem.
If
Yeah.
anyone has any question, please write it on, type it on the comment below. So we should like ask the engineer to answer it. Also, please, engineer Tulo, could you please provide us the link for the video for the audience to have it?
Yes,
Because
I will
we got
provide.
some concern here about it.
Yeah, I will. Do you mean after the presentation, the webinar, right?
Yeah, no problem.
Yeah.
Yeah.
Yeah. Uh,
Any
maybe
question?
maybe I'll put the links to the videos in the chat so everyone can see it, I guess.
Yeah, that will be great. Thank
Yeah.
you so much.
Yeah. I'll just do that. Hold on. Maybe maybe I should have done this initially. uh, and then you have this
If you can,
system.
if you can, we can do it. Yani, if not, at the end of the webinar.
Yeah. Okay. So you have the two videos. The first one was the one which I couldn't get to work on the yeah. Let me see. Sorry, Amit, do you want me to play the video? Or
Uh, yeah. Did you? Yeah, you just. I think. Provided. Just a minute. I will
okay.
share the. Would like to thank you so much for the amazing webinar today, and we have the appreciation certificate. Uh, Thank you so much for uh, for the great webinar, and I hope the audience benefit from it and find it uh, useful and fruitful.
Thank you. Thank you. Thank you for having me.